Okay, folks, let's do some examples of multiplication of at least involving a fraction. So here I've got a whole number times a fraction. Second example, I'll do a fraction times another fraction. But let's see what we've got here. Alrighty. So I'm going to do this with using nothing but the definition. So I'm going to demonstrate that on a number line. I'll try to talk my way through the process as we go through that. So I'm not taking any kind of shortcut, any kind of rule. Things that I can use, though, is the definition of multiplication. So anything that we covered in 107A is fair game now. And if you're thinking, well, we covered multiplication, so I can just do this. Remember, though, we never discussed fractions in 107A at all. So anything we're doing with fractions, we're kind of building up from scratch. However, we do have our multiplication. And so just to refresh, m times n, and I emphasize this a lot, this is the how many and then of what. So this is the number that we're sort of counting up or adding up, and this is telling us how many times we're doing that. So the notation that you saw in 107A would have looked something like this. N plus, use some ellipses because we don't know exactly. We've got a variable right here. But I'm adding up n a bunch of times, and then I've got m of these. M of the n's, right? Or m groups of n. Okay, so if I've got a whole number times a fraction, that's a little bit easier to sort of make jive with our original definition, because that means I'm just adding up this quantity that many times. So it really becomes an addition problem, and the way we can show addition on a number line is kind of just taking a bunch of jumps. So in other words, this would tell me the size of my jumps of length n, and then I'm taking m of those jumps. So I'm going to take 4 jumps of 5/9 and figure out where my destination is. So that's the goal. So I want to set up a number line. A couple things numbers that I need to plot on the number line. So I'm going to be taking jumps of 5/9. So I want to show where 5/9 lives. And for that, I'll step through my definition. I don't necessarily need to show where the whole number 4 lives, because 4 is going to be how many jumps of length 5/9. So the 4 is going to get demonstrated once we start taking jumps. Okay? Let's think about, though, if I need to show 5/9, 4 times 5/9 is going to be a larger number. So it's going to be further to the right. How far do I have to set up this number line? How do I need to go to 10? Do I need to go to 100, right? How far to the right do I have to set this up? Because I want to kind of build it to the scale. I want to make sure it fits on my board here. So if I had 4 times, I know 5/9 is less than 1, right? If I had a whole, split it into 9 groups, 9 segments, and only collected 5, I don't have quite the entire whole back. So if I did 4 times 1, that's something we can do from Math 107A, and we know that that equals 4. So if I did 4 groups of 1, I'd be all the way to the whole number 4. Here I'm taking 4 jumps that are smaller than 1. And so if I bring my number line out to 4, I know that I'm plenty far, right? We're going to get not quite that far. But that's plenty far. Maybe it's a little bit too far, but that will work. So let me set up a number line here. I'm going to draw a vertical for where 0 is going to live, and let me just come way, way, way over to the right. Okay? I'm going to do my best here now to, sometimes I use the eraser, and I could form 9 segments and then place the 1, but I want to make sure that everything fits here. So I'm going to start by plotting, not this 4, but remember, I'm just gauging that I want to go to the whole number 4, because I think the answer will be somewhere down towards that. And then I'm going to backtrack a little bit. So let me put the 4, make sure it's visible here, whole number 4. And so now I'm going to work backwards and try to establish my whole. So, and I'm striving for equal length segments. Again, there should be enough explanation what I'm going to say that the answer should become obvious. So I shouldn't really have to rely on the picture. However, the picture is the visual aid. We want it to match what's going on. So we do want to strive for equal length segments. Halfway between 0 and 4 is 2. Okay, so I'm just getting my whole numbers here. And now between 0 and 2, let me put a 1. And between 2 and 4, let me put a 3. Okay, so I've got a hole, a hole, a hole, and a hole. So we've established our holes. Between 0 and 1 is where 5/9 is going to live. Okay, so now what I've got to do is split this hole into 9 equal segments. And generally speaking, if we split something, part of our line, maybe we want to split more of our line, because we're going to be taking jumps of 5/9. So we kind of want to establish 9 little segments in each of our holes. 9 segments means I'm going to write 8 little tick marks in there. Right, so not super easy. In other words, I don't know exactly how wide they're going to be. What I don't want to do is this: 1, 2, 3, 4, 5, 6, 7, 8. right? That's not great. I want to try to make these look good. So I kind of want 4 and then 4. So let me see if I can do this. So 1, 2, 3, 4, 5, 6, 7, 8. I felt like they were getting a little squashed there, so I don't know if that looks perfect, but it looks pretty good. Okay. So let me just kind of darken those up a little bit. So I see now 1, 2, 3, 4, 5, 6, 7, 8, 9 small segments right there. And let me do that. So I'm going to put 8 marks. I ended up botching that up. Let me try to improve that. Not make them so thick. So I want 1, 2, 3, 4, 5, 6, 7, 8 little marks. And as long as all those holes were around the same length, they looked pretty good, then that little length segment should kind of work out. So again, I'm putting 8 marks because that makes 9 little segments. So here, let me put 1, 2, 3, 4, 5, 6, 7, 8. So I've got 9 segments there. Let me keep going. 1, 2, 3, 4, 5, 6, 7, 8. And let me try and do this one. 1, 2, 3, 4, 5, 6, 7, and 8. Okay? Am I going to bet money and claim that that is perfect? No, but it looks pretty good. All right, I'll give myself credit there. I think that looks pretty good that I've got those segments. So I split my hole into 9 equal segments. I split all my holes into 9 equal segments, so I've got some kind of regularity now. And now what I want to do is locate 5 ninths. So remember, our definition was establish the hole, split the hole into B equal segments, where B is the number in our denominator. So split it into 9 equal segments, and then shade or collect or jump over or move over 5 of those segments. So now if I go 1, 2, 3, 4, and 5, I'll kind of shade those a little bit, and let me label that tick mark as 5 ninths. Okay. So at this point, you're thinking, okay, I'm showing this on work. I'm writing this up as a homework problem. What do I have to show on the line? What do I have to write down? And what do I have to explain? So I see 0 and 1. So it's obvious. I see a hole. I can count that the hole's been split up into 9 equal pieces. So as long as they're equal, and that's obvious, and I see the 9 right there, do I have to really explain or write anything at that moment? I'm going to say no. I think that's okay. However, if you want to write something, do it. So again, don't try to rush or feel like the homework's better if it takes you less time to get it done. Whatever you think is the most illustrative. So if you thought if you handed your paper to somebody and it would be better if you said, I established the hole, I split that hole into 9 equal segments, and then collected 5 of them and labeled the 5 ninths. If you want to explain that part, you can, okay? I think that's kind of obvious though. Now, I want to show that I'm going to take 4 jumps of this 5 ninths. And so again, I'm going to show 1, 2, 3, 4. I'm going to show the jumps. Maybe then I'll justify a little bit of explanation. So rather than just try to take these jumps, let me sort of mark off maybe in a different color where the endpoints of these jumps are going to live. So here I've got 1, 2, 3, 4, 5 segments. Let me do another 5 segments. And so I'm just using these other colored pens right here. Let's say I've got 1, 2, 3, 4, 5. All these segments are ninths, right? Because my hole was split into 9 equal parts. This hole is split into 9 equal parts. This hole is split into 9 equal parts. So each one of these little segments, no matter where it lives on my number line, is a ninth. They all represent 1/9 of a whole. Okay? And so if I do 1, 2, 3, 4, 5, collect 5 of them, I've got that distance right there from here to here is a distance of 5 ninths, right? So that's a jump of 5 ninths. So let me keep kind of indicating them, and then I'll demonstrate my jumps visually. But first, let me figure out where they're going to belong. So I've got 5 red dots right there. I've got 5 green dots. Let me go another 1, 2, 3, 4, 5 of those. So I'm forming collections of 5 of these ninths. Every time I do that, I'm moving over another jump of length 5 ninths, and let me go 5 more. So let me say 1, 2, 3, 4, 5. Now I've got 1, 2, 3, 4 groups of those 5 jumps. And so this mark right here, let me lengthen that up. That's my answer, right? So let me put a question mark. I'll put it up top. Let me put a question mark there. I don't know exactly what that is yet, but Let me figure that out. Let me show now. So I see groups of 4, but let me now show the jumps. So I'm going to take a jump. So to the end of the red dots, a jump to the end of the green dots, which is 1, 2, 3, 4, 5 more segments, a jump to the end of the blue dots, and finally a jump. Okay? Let me write that out. I'm just going to say I took 4 jumps of length 5/9, or 4 jumps of 5/9, and ended here at question mark. Okay, so I know what the answer, I know where the answer is. I now just have to say what it is, right? I have to clarify what that is. Again, I want to label that now in terms of our definition. So I've got holes. They're split up into equal segments. So each hole is 9 segments all down the line. So I've done that. So there's an easy way, and then or I should say a straightforward way, and then maybe a clever way of trying to sort of calculate what's there. The straightforward way is whatever that line is, I know that its denominator is 9. All right. How do I know that? Because every hole was split into 9 equal pieces, right? So that's the second step of our definition. We have holes here. They're all split into 9 equal pieces, which means the denominator is 9. Now I just have to see how many of those I've collected. So let me just count. That's the straightforward way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay? No big deal. So yeah, so we've got that, so I can call that 20 nights. That's fine. I took 4 jumps of length 5 nights. Another way to describe that is I took 4 jumps of, let's say, 5 small segments. Okay, that's also fair. So here I'm using the fraction to sort of explain the length of the jump. Here I'm using a whole number, and I'm explaining it in terms of the small pieces. So that's kind of nice, actually. That's a little bit, either way is okay. But now if I took 4 jumps of 5, so that this literally means 4 groups of 5, which is 20 small segments. Right? So I can reason it out like that, and that works as well. If you're thinking another way, maybe, is the question mark. Okay, I see the whole number 2, and then I've got 1 2/9. So 2 and 2/9. Okay, so we talked about those types of numbers in class a little bit. That is what's called a mixed number. So if you represent it as a mixed number, that's okay. Sometimes we want to find those. But if we want to express it, if they don't specify, we want to find it like this. Not a mixed number, just a straight fraction. So how could we justify that 2 and 2/9 is the same as 20/9? So again, I'm going to talk my way through this, but or maybe I should write it up. We have 2 holes and 2/9. Okay, so there's really sort of addition going on there. We're collecting them all together. I've got 2 holes and then 2/9. Each hole was split into 9 equal pieces or equal segments. Okay, so I guess I don't need this portion of the line there. We've got 2 holes and then 2/9. Each hole was split into 9 equal pieces. So how many groups of 9 do we have? 2, right? Each hole is a group of 9. So we have 2 groups of 9. 2 groups of 9, or 2 times 9. So translate that into math notation, or 2 times 9 is 18 small segments or pieces. Okay? And that's up to the 2, right? So what we just did was we started with 2 holes. Each hole is split into 9 equal pieces. So we have 2 groups of 9. 2 times 9 is 18, so we've got 18 little pieces. Then we have 2 additional pieces. Then we have 2 additional pieces. this line right there. Let's sound fancy. Thus, we have, I'm explaining this in terms of whole numbers. We had 18 pieces, now we have 2 additional pieces, so thus we have 18 plus 2, which is 20 pieces, right? What are our pieces? Our pieces are ninths. Because of our definition, we split our whole into 9 equal pieces. So we've got 20 pieces, each piece is a ninth. Therefore, or hence, if you want to get real fancy, therefore we have 20 over 9. We have 20 over 9, let's just say. I don't want to say 20 over 9 pieces. The pieces are the ninths, so we've got 20 ninths. There we go. All right. So, if you're thinking, that's really wordy, do I really have to write that every single time? Let me phrase it this way. If you didn't write any of that, and you, well, that's explaining how we converted. So I guess you want to explain that. If you didn't show that, or you didn't give any kind of explanation, and you just gave somebody this picture, right? And then you said, okay, the answer is 20 over 9. Let's think about what they could ask. So I don't know if you guys use the terms, the people Max and Molly, those hypothetical students in 108. Let's say somebody just looks at this and says, okay, I don't get that though, right? I don't see what's going on in that picture. So we might understand it as we write it up. But if you think maybe it's unclear, of course you can always back things up with sentences. If you feel like you're writing a paragraph, that's okay. That's an explanation, right? So we have to teach by explaining things to folks. And so when I speak, I'm aiming to craft full sentences when I talk. If I'm writing, I'm writing full sentences. And so yeah, so a lot of folks feel weird explaining math. They think the numbers and the pictures do all the explanation. But again, my little mantra is, when in doubt, write it out. Okay, I'm going to try to do a lot more examples like this, because it's not that I'm asking you guys, write pages and pages and pages for your homework that I'm not willing to also do. So I'll be there right with you. So if I can write it, you guys can write it. And there we go. So I'm hoping that the more of these examples that we look at, you guys, I say guys, you folks, ladies and gentlemen, will feel a little bit more comfortable with your own write-ups. So try not to think, and I don't want to tell you guys how to feel, but try not to think that like, what does he want, meaning me? What does the teacher want? Let me just do it the way he wants it. Instead, try to challenge yourself. Be like, what could I do to make this as clear as possible? Let's say you live with your parents, or you live with a younger sibling would be great. Someone who's not in this class doesn't understand our definition of a fraction. If you ask them to look at your write-up and say, does this make sense? Do you see how my work here shows this demonstrated and how I arrived at that answer? And if they can, without you explaining it, because the explanation is written down, if they can look at what you wrote and read through and be like, yeah, I see what you did, you explained it well here, then you've succeeded. If they look at it and say, this is like a picture, but what was your first step? What was your second step? Then you kind of answered yourself. Is that explanation thorough enough? If someone can read it and have to ask further questions, then I would say then the answers to those questions kind of should be embedded in the explanation to begin with. Okay? So, getting philosophical towards the end there, I will stop this recording, do another one where we'll do a fraction times a fraction. Going to work it out on number line as well, though. Alrighty?